just enter there. In case of spherical mirrors, if object distance x1, small x1, and image distance small x2, object distance x1 and image distance small x2 are measured from focus, instead of pole. Now see what we are trying to explain. We are having a concave mirror. This is the point which we call it as pole. This is the horizontal line which we are calling it as a principal axis. Okay? We are having this point called as focus. You are calling this point as center of curvature. Suppose we are having the object present here. This is the present position of the object. And from the object, we are measuring the distance of object as x1. From the focus. From where we are normally measuring the distances? From the pole. Now from where we are measuring? Focus. So is the focal length going to change of the concave mirror? Focal length depends only on the radius of curvature. It will be remaining constant. So I will be able to write down the image object distance u will be taken as minus of inner bracket f plus x1. Right? Now where will be the image formed? Because it's a concave mirror, beyond C, you are having the object, where will the image formed? Between C and F, somewhere it will be formed. So let me assume that the image is formed here. It will be real or inverted. What will be nature? Size. So you will be able to show like this, somewhere like this. This is the image. Now if this image is formed at a distance of x2 from the focus, then image distance will be taken as minus of f plus x2. So if you are applying it to the formula 1 upon f is equal to 1 by v plus 1 upon u, you will be able to have 1 upon minus of f plus x1 plus 1 upon minus of f plus x2. Am I right? So we need to solve this part. So how we can proceed ahead? This will be minus is there, so you will be able to have, I can put it as minus of 1 upon f inner bracket 1 upon f plus x1 plus 1 upon f plus x2. I have taken minus sign common, shifted to the left side. So this will be giving me a relation as f plus x2 plus f plus x1 divided by, you are having f plus x1 multiplied by f plus x2. So if you further solve it, what you will have? This will be giving you minus of 1 by f is equal to x1 plus x2 plus twice f divided by, you are having here f square plus x1f plus x2f plus x1x2. So taking the product here, it will be minus of f square minus of x1f minus of x2f minus of x1, x2, that is equal to x1f plus x2f plus twice f square. I am taking this f to this side and this term to this side. So what you will have? One thing is missing here. What is the focal length of the concave mirror? So I have taken it positive. बराबर है ना? So यहाँ पर एक और निगेटिव साइन आएगा ना, यहाँ पर -1/f ऑलरेडी रहेगा, तो ये सारे चीजें निकल जाएगी और सीधा प्लस ही आएगा, यहाँ पे 1/f ही आएगा. और अगर ये 1/f आता है तो यू विल बी हैविंग दिस टर्म टू बी टेकन एज प्लस एफ स्क्वायर आएगा, प्लस x1f प्लस x2f प्लस x1 x2 आएगा. So you will be having x1f getting cancelled from this side, x2f is also getting cancelled, f square transferred to this side will be giving me f square is equal to x1 x2. So the focal length in that case will be given by under root of x1 x2. This formula was derived by the person well known to you, and that is known as Newton's formula. So just write down the derivation there. So while handling the problem, you should take care whether the distances are measured from focus or the pole, that you have to check it out. So without drawing the figure, please don't try to jump on the formula, because that may give you the different answer. So what is the mirror formula? So you are having a mirror formula 1/v plus 1/u is equal to 1/f. Now plot the graph between v and u, or 1/v and 1/u. What will be the nature of graph between 1/v and 1/u? What will be the nature of graph for this equation? जोर से बोलो. How do you plot the graph? With pencil, scale, graph paper. How do you plot? Now, if I write down 1/v is equal to y, 1/u is equal to x, and 1/f is equal to some constant c, then my equation would appear to me y plus x is equal to c. So can I write down this equation y is equal to minus of x plus c? If I compare it with the standard equation y is equal to mx plus c, you are able to write down m is equal to minus 1. So what will be the nature of the graph here? Loudly. With a negative slope. So how should I draw that graph? So do you know what is the nature of straight line graph? निकाल सकते हो आप? I'll show you. So you can show here this as the graph for a line whose equation would be taken as y is equal to mx. The slope of the graph is positive. You will be having another line parallel to it. It will be having the graph y is equal to mx plus c. There will be another graph, parallel line would be shown here. This is y is equal to mx minus of c. Then you will be able to show the next type of a graph which will be starting in this manner. This is representing the equation y is equal to minus of mx. I can draw another graph here in this manner. This is representing the equation y is equal to minus mx plus c. Then I can draw another graph parallel in the same manner here, and I can have here y is equal to minus of mx minus of c. Then I will be able to put down a graph here in this manner. This is representing the value of x is equal to constant, positive constant. There will be another graph with this part that is representing x is equal to minus of constant, because the value of x is remaining constant, y is changing here. On the other hand, I can have one more graph here with this line that is showing me that the value of y will be taken as a constant. Y is equal to plus b, I can say, and I can have some graph here that will be representing y is equal to minus of b here. Any constant. With a different slope, you can have different lines drawn. So these are different lines and their different equations. इसमें से कौन सी लाइन निकालना है वो मैं पूछ रहा हूं पहले ग्राफ के लिए. माइनस एम एक्स प्लस सी. कैसे निकालू लाइन? The point is the value of c is going to be a constant. So you need to understand this 1 upon f will be a constant, so that value is taken as c here, right? तो कहां तक निकालूं मैं? Should I move below the x axis, above the y axis? कैसे? This side will be taken as 1 by v, this side will be taken as 1 by u. The nature of graph would be appearing to you like this, and this distance from here to here will be called as c. This distance from here to here will also be called as c. The reason is very clear. When you are having the value of 1 by u 0, when you are taking the value of 1 by u 0, so this is the point. The corresponding value of 1 by v will be equal to 1 by f, that is equal to c. इसलिए मैंने ये वाला distance c बोला है. Similarly, when you are taking 1 by v is equal to 0, you will be having 1 by u is equal to 1 by f is equal to c. So in that case 1 by u distance will be taken as c. So ये जो distance है यहाँ से यहाँ तक का, that will be taken as c here. This will be the nature of graph. Are you getting the maths? कैसे ग्राफ निकाला गया समझ में आ रहा है? कंप्लीट करो ये प्रोट. So again we are having the same formula here. 1 by v plus 1 by u is equal to 1 by f. If u is equal to infinity, what will be the value of v? If object is at infinite distance, what will be the value of image distance? It will be taken as v is equal to f. Similarly, if you are having v is equal to infinity, then object must be at the focus. We have seen this, right? Now in this case, if I want to plot a graph for v against u, then I will be drawing first a dotted line parallel to the v-axis. This is telling me that the value of u here is equal to f. This is leading to infinity. Similarly, I will be having here this horizontal line to be drawn, telling you that this will be the value of v to be equal to f when you will be having the value here moving to the infinity, value of u moving to the infinity. But if you take here the value of v is equal to twice f, what will be the value of u? Why? Yes, correct, because you are at the center of curvature. If image is formed at the center of curvature, object must be at center of curvature. So you will be having here the value of u that will be taken as equal to twice f. Right? Now if you are able to show here twice f, you will be able to double this. So this will be the point here. And I will be able to draw the vertical line showing you the value of twice f here. Similarly, I will be drawing double the value here, showing you twice f at this particular point. So this particular coordinate will be having the value of twice f as well as twice f. So you will be able to get the nature of the graph which would be passing in this manner. It is a rectangular hyperbola with intersection from the origin to this particular line. This point of intersection is twice f, twice f. This is the nature of graph between v and u. This will be the nature of graph, it will be hyperbola. So in car, which type of mirrors are used? Why you are using convex mirror? You don't want image? Inverted image nahi chahiye. So it is producing a virtual image. It is an erect image that is produced by the convex mirror. Yes or no? But that is also true with the plane mirror. Plane mirror also produces virtual and erect. So we can use the virtual plane mirror to get that erect and virtual image, which is produced by the convex mirror also. Why? Are you able to understand the question? Plane mirror and convex mirror are both producing erect image, virtual image. Then why we are going for convex mirror rather than a plane mirror? Clear image, and plane mirror do not produce the clear image. It is written on every convex mirror that the person is appearing closer to you. So it's not a question closer, so it should be a plane mirror only, na? So आपको you will start thinking that the small object is coming. How can you say that? You should be able to prove it, no? Convex mirror is converging or diverging? Convex mirror. I'm trying to show here that the size of both the mirrors are equal, plane mirror as well as a convex mirror. Now you will find that in this case a ray of light can come from this side, strike here at the end and move on to this side. Similarly, a ray of light can come from this side, strike here and move on to this side. So this is actually a range at which you can see the things behind. But for a convex mirror, the ray would be coming from the other side, like this, and will be getting reflected onto this side. It can come from this side here and will get reflected onto this side. So the range here would be from this part to this part. So to cover a maximum range behind, we are preferring convex mirror over the plane mirror. It covers a bigger range of wide vision. You need to have a wide vision of a back, therefore we are using a convex mirror there as compared to the plane mirror. So you can check it out from the rays itself that how wide range of rays can be made incident on a convex mirror. Write down a question there. Write down a question. If a luminous point is moving at a speed, if a luminous point is moving at a speed capital V suffix 0, capital V suffix 0 towards the spherical mirror, towards a spherical mirror, comma, along its axis, find the speed along its axis, find the speed at which image of the object is moving, find the speed at which image of the object is moving. Should I start solving the problem? Or will you be able to get the answer? So tell me, what is a mirror formula? So you are having 1 by V plus 1 by U equal to 1 upon F, right? Now differentiate this equation with respect to V. What you will have? Now you are at trouble, right? And that is why I have given you some formula that was to be remembered by you. D by dx of x to the power a is equal to a x to the power a minus 1. So if I want to find out the derivative of all this thing, I will be having d by dv of 1 by v plus d by dv of 1 by u is equal to d by dv of 1 by f. Do you remember I have told you what is the meaning of dy by dx? Dy by dx, I have told you the meaning of that. What is that meaning? No, what is the meaning? Change in y upon change in x. Right? So here I am having change in 1 upon focal length divided by change in the image distance. U and V are standing for object distance and image distance. So I am taking here the change in the focal length upon change in the image distance. So what will be the change in focal length if the image distance goes on changing? So focal length is going to remain constant. So 1 upon focal length will also be constant. So what will be the change? So 0. So right hand side will produce a 0 here, and we will be having here d by dv of v to the power minus 1 plus d by dv of u to the power minus 1 is equal to 0. Are you getting why I am getting here a 0 on the right hand side? Getting everyone? Now what is d by dv of v to the power minus 1? You have to use this formula. So you will be having minus of 1 multiplied by v to the power minus 1 minus 1. यहाँ पर क्या आएगा? प्लस minus 1 multiplied by u to the power minus 1 multiplied by du by dv. Because here u and v are the function of each other. If your u changes, the value of v changes. If your object distance is changing, is the image distance going to remain the same or is it going to vary? So we are writing here variation of object distance with respect to the image distance. Right? यहाँ पर भी मैंने लिखना चाहिए था dv upon dv. But dv upon dv is 1. Change in velocity, change in image distance upon change in image distance, that will be always 1. That is why I have not written here. So that is again equal to 0. So if you solve it, you will be having here minus of 1 upon v square minus of 1 upon u square into du upon dv equal to 0. Am I right or wrong? So can I write down this relation minus of dv upon v square minus of du upon u square is equal to 0? Can I write down? So I can put it down here, minus of dv upon v square is equal to du upon u square. Can I put it down like this? So I will be writing here dv is equal to minus of v square upon u square multiplied by du. Can you get the step mathematically up to this mark? Now if I further differentiate it with respect to time, I will be able to write down this relation as dv by dt is equal to minus of v square upon u square into du by dt. What is du by dt? What is du by dt? किसकी स्पीड है? Object ना, so it is denoted by what value? Question पढ़िए ना, वहां पर दिया है v naught. So I am having this as v naught and this is representing vi. So you will be having here vi is equal to minus of v square upon u square into vo. ये एक फॉर्म हो गया. Are you getting this step? Another important part, we have started with this 1 by v plus 1 by u is equal to 1 upon f. Can I write down 1 by v is equal to 1 upon f minus of 1 upon u? So this is giving me u minus f upon uf. So value of v will be taken as uf upon u minus of f If I'm calling this as equation 1, I'll call this as equation 2. So I will be able to write down here Vi is equal to minus of u square f square divided by u minus of f whole square and multiplied by here u square into V naught. So factor u square is getting cancelled. You are having Vi is equal to minus of f square upon u minus f whole square into V naught, or I can rewrite this as Vi is equal to minus of f upon u minus of f whole square into V naught. So image speed or speed of the image will be obtained by this formula f upon u minus f whole square into velocity of the object. Any step you want me to repeat or explain? Now, best way to find out what is your difficulty is to first go through the complete solution and then without looking at the board start deriving from that particular step. Jahan aap ruk jaoge, where you will not be able to proceed ahead, you can see the solution, understand it, or ask me the question and proceed ahead. And in that manner, if you complete the derivation, your understanding will be more. You want this step? So this you have got it, minus 1 into v to the power minus 2. So v to the power minus 2 is 1 by v square. Then you are having minus of u square, minus of 1 upon u square. This term is du by dv. That is there itself, equal to 0. Then what I have done, I have multiplied throughout by dv. So if you multiply throughout by dv, dv into 1 upon v square, that is minus dv by v square, dv into dv, ye dv cancel ho jayega. So you are having minus du upon u square equal to 0. Don't copy step by step. Have a complete look at the proof. And once you start writing it, don't try to look up. At least 6-7 steps you are writing, then you are having a difficulty. Find out where you are having a difficulty, what is the reason for the difficulty, understand it, and then again solve it. That will be helping you to prepare the topic easily. I've told you that you can write down dv upon dv with respect to v also. First part, minus of 1 by v square dv by dv. But dv and dv will be getting cancelled. That is why we have to keep du by du by dv. That set got cancelled, dv upon dv is getting cancelled there. Now write down a problem. An object of length 10 centimeter, an object of length 10 centimeter is placed at right angles to the principal axis of a mirror of radius of curvature of radius of curvature 60 centimeter such that its image is virtual, erect, such that its image is virtual, erect, and has a length of 6 centimeter. what kind of mirror it is, and determine the position of the object. Now I'm expecting you to get the answer of your own without my help, because that background is sufficiently created before you. First write down whatever you want to find out, object distance and all of the stuff you completed, then raise your hand if you have got the answer. So there are two parts in the question. Which mirror it is used? So one answer is got by everyone, convex mirror. Right? Now if it is a convex mirror, then in case of convex mirror, you are having magnification positive or negative? So what you have taken a magnification, negative or positive? If you have taken a negative, it is an inverted real image. If it is positive, it is a erect and virtual image. So as per the description in the problem, that image is virtual and erect. It has been given to you. What is magnification? Size of image upon size of object. Size of image is 6 centimeter. Size of object is 10 centimeter. So 6 by 10 will be the ratio. That will be 3 by 5. So M will be taken as plus 3 by 5. If you are taking M as plus 3 by 5, the formula for M is minus of V by U. So minus of V by U is equal to 3 by 5. Use the formula 1 by V plus 1 by U is equal to 1 by F. If it is a convex mirror, then focal length will be calculated by R by 2. Radius of curvature is 60 centimeter. R by 2 will be 30 centimeter. Focal length of a convex lens, convex mirror, positive or negative? Substitute the positive value and get the answer. Minus 20 centimeter from the pole is the answer for that. So how many of you have got this answer? Minus 20, 1, 2, 3, 4, 5, 6. Some calculation error has gone there. The steps are clear. Calculate the focal length by using the relation R by 2. The focal length for the convex mirror will be positive. Okay. Then as it is given to you virtual and erect image, you will be having magnification that will be taken as plus. Size of image is 6 centimeter. Size of object is 10 centimeter. So it is 6 by 10. 6 by 10 is 3 by 5. So 3 by 5 to be equated with minus V by U. Calculate the value of V. Substitute it in the relation 1 by V plus 1 by U is equal to 1 by F. Solve it. You will be able to get the value of U. The object distance is 20 centimeter from the pole in front of the convex mirror. That formula can be also applied, M minus 1 into F, that we have derived. So this is all about the curved mirrors. We have done it in a detail with every minor aspect has been covered. We'll continue with problems tomorrow, and after the problems we'll start with refraction at the plane surface. So we'll proceed for tomorrow's session. Okay, see you. Bye.